Assalamualaikum warahmatullahi wabarakatuh. Good afternoon everyone. Thank you for attention and watch my presentation in Simposium Kebangsaan Sains Matematik 29. First of all, I will introduce myself. My name is Dian Pratama. I am a student PhD in University Malaysia Terengganu. My topic is Fuzzy Matematik. And here is my supervisor is Dr. Binyamin bin Yusuf, and second supervisor is Professor Dr. Lazim Abdullah. Today I'm going to share and present our research. The title is Some Operation on Circular Intuitionistic Fuzzy Set. Okay, let's start from motivation. We start with the question, do you agree that men are better than women? Now, let's talk about the real condition, which will appear uncertainty in the answer, like abstain, or something like that. And then the set, which is characterized by an uncertainty degree, is called Intuitionistic Fuzzy Set. Or we call IFS. It's defined by Atanasov. Let's make illustration about IFS. We can see on screen, there is a polling before the president election process of USA, about United States of America. It is clear that membership function of Biden is 0.52 and membership function of Trump is 0.43. In the other words, we can say the non-membership Biden, it means not choosing Biden, but choosing Trump is 0.43. and vice versa. From this data, we can know the value of uncertainty degree is 5% or 0.05. And this is the representation in geometrical. And this set, its interpretation of intuitionistic fuzzy set. We get another case. What if there are another institution that want to predict the result of the election calculation? In example, we get 3 institutions, let's say corporate A, corporate B, and corporate C. Okay, this is the illustration. Okay, this is the result. This set called circular intuitionistic fuzzy set, defined by Atanasov in 2020. So this is the definition of circular intuitionistic fuzzy set, or we will call CIFS. Some general form of the properties of CIFS. The left side is operation in IFS, and then the right side is operation in CIFS. We start with subset. With IFS, we get A subset B. In CIFS, we can define 3 types of subset. Same as operator superset. The superset nu, superset row, and pure superset. And also, it has same with equal. A equal B. This one is AR equal nu, AR equal row, and ER equal pure equal. The next is negation operator. Okay, say negation A in IFS like this, and then negation AR is like this. Okay, that is something different. Okay, next is arithmetic operator. The left side in IFS, there is 5 operator. Intersection, union, plus, circle, or product. And then add is min. In CIFS, we can define 2 types of each operation. As example, this is the intersection. If we know the intersection is IFS is just 1, but in CIFS there is 2 operations. Okay, intersection min or intersection max, which is this is effect with the radius. Okay, because CIFS we have membership function, non-membership function, and then radius. So the min or the max, in this operator, it affect with radius. This condition is same method with AR union, and then plus, and then product, and then add, like this. Okay, what's the problem? The question is why previous operator in CIFS, especially radius, only max and min. Okay, that I say before, if I have intersection min and max, there is no one except min and max. So, is there any possibility for define another operation in radius? Okay, this is the problem. And now, I define the operation of radius in CIFS, and we call extension operator in CIFS. This is based from the basic arithmetic operator. Then min and max is just defined by Atanasov, but I define plus and then circle and then add, because it affect with the radius operation. Okay, and then the main result of 2 is how about the negation operator? Let me know before if Atanasov define this one, and then I try and I define 2 type of negation operator. These 2 negation operator, we call it negation 2 because it's a fulfill boundary condition, monotonicity, continuity, and involution. Okay, and then the next question is how about the properties for new operator? Okay, I have 4 theorem. Okay, with the let's say the basic first is a theorem 1. What the objective in theorem 1 is I can get relation between the radius. If I have plus and radius dot, and we get plus radius min, we get plus radius add, plus radius maximum, and then plus radius plus. So the relation is subset base row. The tree of the point is the same. And then the second theorem is just generalized with the previous theorem in IFS. I think it's very clear. And then the third theorem, I try to making a relation between previous negation, and then we can something like combine with the new negation. And then the fourth theorem, this is for equality between CIFS if we get AR and BS, and then the operator we say intersection, union, plus, and then dot, and then add. Okay, this is the properties. And finally, we get the conclusion. The conclusion of this research is based on interpretation. The intuitionistic fuzzy set can be divided to several sets, one of which is circular intuitionistic fuzzy set, like as before CIFS. This set is a set whose elements are circle. Any element in CIFS means a circle with the center of membership and non-membership coordinate, we say mu x and nu x, and the radius r. This set is another form of IFS generalization other than IVIFS. Operation on IFS can also be derived in CIFS. However, it does not only focus on membership and non-membership function. It is necessary to have operation in the radius. After the operation radius has been proven on the CIFS arithmetic operator, further research needs to be proven for more specific properties in algebra, like including commutative, associative, involution, De Morgan, and many others. This process needs to be carried out to support the application of CIFS in decision making. And this is the reference. Okay, I think it's all. So thank you for the attention. If there is input for any participant, inshallah I am ready to accept it. So thank you. Wassalamualaikum warahmatullahi wabarakatuh.